All right. Well, good morning, everybody. Thanks for starting your morning with me here. Excited to talk about what it's like being an electrical engineer and some things about Chicago Engineers Foundation, the organization I'm representing today. So there's a picture of me. I work at Kimley-Horn. We're a multidiscipline engineering firm. So we have structural, civil, landscape architecture, and MEP. The MEP stands for mechanical, electrical, plumbing. I'm a part of that group. I'm an electrical engineer. I earned my Master of Science in Electrical and Computer Engineering from IIT in the city, and I got my bachelor's degree from SIUE, which is Southern Illinois University. That was also in electrical and computer engineering. My role at Kimley-Horn, I'm a practice builder and an electrical engineer. Practice builder, what does that mean? I think this is kind of a unique term to Kimley-Horn that they like to use. It means I'm kind of like an entrepreneur within the company. I'm building my own practice there, so I'm developing my own client base, and it, I, I'm choosing the kind of projects I'd like to work on, and it's kind of neat. It's like running a company within a company. And so my school progression, very like familiar with the city of Chicago. So I went to school in the city of Chicago, on Macaulay. Then I went down to Southern Illinois to get my bachelor's degree. After I did that, while I was working my first job, I took the Fundamentals of Engineering exam, the FE. So we'll talk more about that on the next slide. This was starting my path to becoming a licensed engineer, which is super important for what I do. While I was working that same first job, I earned my Master of Science degree from IIT, and then eventually, several years later, took the SAT for the professional engineering exam, which is the PE. And so what is the PE? This stands for a professional engineer. In the same manner that I think most people are familiar with how architects stamp drawings. You can see in the picture there, somebody's applying a rubber stamp to the drawings. It's basically like taking ownership or certifying that to the that you've used to the best of your care and knowledge, that you're saying I've done these drawings, like you're taking care to, I guess, accept, responsibility. Um, it's really important in the field of engineering that I'm in to have this license. It's expected, it's needed if you want to move up at work. And there are certain jobs you just wouldn't be able to have without having the license. For example, you wouldn't be able to be the head of a department without it. You wouldn't be able to, if you are interested ever in kind of running your own business, even if it's within a company like I'm in, you would have to be a licensed engineer to do that. And this shows my career path. I have been doing this for about 23 years. So you do see a handful of places there, which is kind of, normal to see that. Um, the longest stint I stayed somewhere was 11 years. But basically, it's not good to switch around a ton. You should. It kind of looks bad on resumes to do that. So I started out at close to where I went to SIUE in St. Louis at Parsons Brinkerhoff. I eventually moved down to Cosentini in the city of Chicago. That's where I was for 11 years. So I felt like I kind of grew up as an engineer there, learned all sorts of things, kind of like really gained my technical foundation at that company. Then I moved on to WMA Consulting Engineers, also in the city of Chicago. And then I was offered an opportunity to run a startup company called Chicago Engineers. That's where I kind of started to get the fundamentals of being an entrepreneur. And then I was offered a role as chief electrical engineer at Epstein, which is architectural engineering firm in the city of Chicago. and then finally ended up at Kimley-Horn as a practice builder. So returning kind of to the more business development side of things mixed with a technical background, whereas the chief electrical engineer position was purely technical. Average starting salary for the type of engineer that I am is around 75,000 a year. I pasted some of these are directly from projects I've worked on recently, just so you can kind of get a flavor for things that we do. This one over here, these are actually from the same project. This is from a residential project, existing building. The client was interested in using an empty amenity space to turn into a studio apartment, which actually the architect was able to make it into a 1-bedroom. You could see the thought was studio at first because it's kind of small, but they're able to sneak a bedroom in there with a door and everything. So what does this mean for me as electrical? So this was an empty space. I actually went to the site and looked at the amenity spaces, nothing in here but a few lights. So we're turning it into an apartment. We need power for the appliances, for the outlets in the bedrooms, for the new lights. There's a washer and dryer in here. So we need to bring power from somewhere, right? And the tenant pays for the power. It's not like we can just hook up to a building panel and get the power that way. So along the outside of the building, they have these, I'm sure you've seen these on buildings before. They have these exterior meter banks. So part of my job when I was at the site was to kind of look at those and to see not only would there maybe be ampacity, like extra power in these, I have to kind of analyze how much power this unit is taking up already, and does it have enough to absorb another apartment unit or another 3, in this case, 3 units. But is there physical space on the wall to add a whole other meter bank? So these are some of the kind of things, just like I feel like it's called an investigation stage where I'm starting the project and I'm figuring out what do we need to do to make this work. So that's part of being an engineer. These are some cool example projects from over the years. One of my first projects was actually circuiting the lights that there's recessed lights around the beam in Millennium Park. So that was one of my first jobs. And that was just, even though I didn't select the lights for the beam, that was done by some fancy artists overseas. But it was still cool to be involved with this because this is a landmark now. This is the Blue Cross Blue Shield building downtown. So quite a while ago, maybe 16 years ago now, they expanded the building by twice the height. So I was the electrical engineer who did the design for the vertical expansion of this building. So that was just a neat, unique project, and this changed the skyline forever of the city. This was my first residential high rise in the city. This is One Museum Park. So also in the city, it's a unique, cool looking building. I like to point it out to my kids when I'm downtown. This is a museum in Racine, Wisconsin, for SC Johnson Wax. I'm sure everybody's heard of SC Johnson. They make all kinds of products. This is a Ronald McDonald House in the city. These are the buildings where families can stay when they have sick kids at the hospital. This was my first airport project that I worked on. This was new construction, Duluth International Airport in Minnesota. And then this is a more recent project. This is really cool, and I hope you guys all visit this. This is called Flyover, and it'll be at Navy Pier, probably opening within the next year. It is a virtual reality ride that's going to go in it was a theater before. It's been empty for a while at Navy Pier. You basically get on this it looks like a amusement ride, and you get to select your experience. Like maybe it's the Grand Canyon or Niagara Falls, and this experience is stimulated through sound, through sometimes they might like put droplets in the air, I think, or this moves around. So yeah, this was just it was a neat project. They have one in Las Vegas. Um, that this was when I was at Epstein, so it was architectural engineering firm. Our architects actually went to Las Vegas for a day, hopped on the ride, um, and then was able to pitch winning the project to the client because they had experience of the ride. So that was a clever business development, like marketing tool that they used there to actually go on the ride so that they could talk about it. Um, so interesting best parts of being the type of engineer I am. Being part of a team. I don't do anything solely by myself. It's a lot of moving parts, lots of partners on my team. Types of projects like the previous slide that I just showed. I don't work on the same types of projects hardly ever. It's a big mixed bag of things, which keeps it interesting. I prefer it that way. And then this kind of links hand in hand with that. Never stop learning new things because every project type, every client, every location, I work all over the country, by the way, not just in Chicago or even in Illinois. Getting the scoop on developments before the public. So Millennium Park was that. Like I remember when the firm I was at won that project, and it wasn't just circuiting for the bean, but it was a lot of the development of that park. We had a big like champagne toast and everything. They knew it was a big deal. And that was years before the park opened up. But so I knew about a lot of these things before anybody else did. So that's part of the cool thing about being an engineer. Being a mentor, eventually when you get that good technical foundation, you can pass on things you've learned to others and see them flourish. And it's really like one of the best parts of being an engineer. And then seeing the final product. So and we'll talk more about this. You guys probably saw the engineering task list I sent out for you to put in order. Part of like tasks that I go through is called a punch list or construction administration stage. So that's like where the project is done. The client wants you to go out and kind of take a look at everything and make sure it was installed per the drawings that you did. So that's always cool to kind of see everything come together. Challenging parts. Of course, it's not all a bed of roses being an engineer all the time. So there's technical obstacles, especially at the beginning of the career. There can be a lot of hurdles. It's not always knowing everything. I still don't know everything. I get asked questions all the time where I have to go and find the answer. It's knowing how to get the answers or who to ask to find them. Difficult clients. So you'll deal with that more like later in your career as you start to become client facing, but sometimes there's uncomfortable conversations that are filled with tension. So that's just the more often you have those, the better you get at navigating. Managing a team. And I can say, I didn't put this up here, but managing the client too. Both of those are very important. And can come with tension. And then keeping up to date with codes and standards. I guess this can be linked to this technical obstacles, right? So after you become a PE, you're required to keep up with continuing education credits. So you have to submit, sometimes if you get audited, you'd have to submit a log, how many hours of continuing education you do every year. So it's not a stagnant thing. Once you become an engineer, you have to keep learning and keeping up with the latest codes. And then, as I said at the beginning, I'm part of CEF, Chicago Engineers Foundation. I volunteer for that organization. We give merit-based awards, and then you can kind of read along here, but it's a total value of $6,000 over 4 years. And we are currently in the application cycle for receiving applications for those awards. So if you are a senior and considering engineering, yeah, I urge you to complete one of these applications. I feel like, because I've looked at the applications before, and I'm also one of the people who reviews these when they get submitted. It's a fairly straightforward, easy process. So yeah, I would encourage anybody who's thinking of going to college for engineering to complete one of these. One of the nice things about the program, there's a lot of like award or scholarship programs where it's just a transaction, like you receive the award and that's it. We keep in touch with you throughout your 4 years. We will, try to assist you with getting an internship, look at your resume, look at your LinkedIn, do mock interviews. So there's so much more than the monetary award that comes with this scholarship. So as part of my slides here, I wanted to work in, before we looked at some of my drawings from a project, wanted to talk about, like something else that I do here from time to time is like a case study, kind of like a report almost, where I'm not producing drawings, but there's a problem a client has and they want us to look into it. So this is one I did many years ago, probably at this point, 15 or 12 to 15 years ago. It was for building management for a condo building. And a few of their tenants had purchased Teslas, but they did not have EV chargers in the building. So they approached me about kind of just trying to figure out what would need to happen with their electrical system in the building to support it was a bunch of different things they wanted to know, from a few EV chargers just to accommodate those who had them right now, to all the way up to support for every tenant. Because when you think about condos, those are owners and they have a condo association. They try to make everything fair. So like ultimately they'd want to make it so if everybody purchased a Tesla, which probably wouldn't ever happen, but that they could accommodate all of them. These things take a lot of power. So, I mean, a level 2 charger, which seems to be the most common for commercial applications like this, takes about 30 amps of power. It's not something that's just usually sitting on a panel, especially not for many of these. So what I did is I went to the building and I looked at their existing electrical system. I use other tools. I'll ask them to pull utility bills from ComEd, and I'll look at the actual usage of that equipment rather than me trying to figure out how much load is used up. And then I'm not only again thinking, just like the other project example I used earlier, it's not only a matter of how much like juice, like power is left in existing equipment to support. You always have to think of physical space, right? So if they're needing EV chargers for every tenant, that's a few switchboards. That's not a panel. Switchboards take up a lot of space. So I also went around the building and identified spaces for future rooms. I said, okay, if you take up these 2 parking spaces in your garage, you can build an electric room here. So it's kind of like, it's just thinking about every aspect of the project and then like folding it into a report. So that way, what the client then does often is they'll give that report to contractors and they'll say, can you give us a price estimate for if you were to, actually build this, so that they can get an idea of cost. Some engineers can also, we can do cost estimates in-house too. We have books and that we can price things. So that wasn't part of this exercise for me, but at least you kind of have an idea of, like some other things that we do other than develop drawings. We also try to help solve problems for clients. So everybody should receive a project steps, but it was out of order. And then the ask was just to put these in order for what you think it should have been, and open to conversation at this point. Just wondering, did anybody think that was hard, or was it pretty straightforward?
Can you elaborate, like just the list or?
Sure. Yeah. Yeah. So I was gonna do that. And then after, like, if you guys have any comments or feedback, feel free to jump in. But yeah, let's go through this in the order. And this isn't always, by the way, this is not like set in stone. Sometimes it will change depending on client or project, or even individual running the project. But this is like in general how I run my projects. So and this is also for the role that I am right now, not for somebody who had just come out of college, but for the practice builder role that I have right now. So how it starts out is giving, client has an issue they want to solve. You have to give them a fee and some kind of scope language, like they're telling you what they need, but then you have to reiterate that back to them in the form of a proposal, so that it's understood, like what it is they're getting. And in that proposal, you'll exclude things, you'll list assumptions like, hey, you're going to give me existing drawings of your building, you're going to give me ComEd bills, things like that. I have both internal and external clients. So our civil engineers sometimes will need electrical components. So sometimes the scope and fee I'm giving to somebody who I work with at Kimley-Horn. Next thing, like, let's say you win the project, all the other bullet points go with assuming you won that project. You would want to develop a schedule. This is really important. You have to understand, like, how much time it's going to take, and reiterate that to your client, and kind of know for yourself how much time you're going to be spending on it and your team. And then you would want to, I guess these can be interchanged, these bullet points. You'd want to assemble a team. You want to have the right people on there. When you developed this fee, hopefully you had some team members in mind. I do that. I don't always have the exact names of people, but I have their levels in mind. The way we structure fees to clients, it's by level. It has, each level has a different billing pay rate that we charge our time for. So I already have my team in mind, and in a very general way when I'm giving this to the client. Um, then it's important to have an internal project kickoff meeting so that you can relay, you can say to your team, hey, we have a new project. You are going to work on this. Here's the schedule. Here's the codes we might follow. Here's some, like, expectations of the client. Um, Anything that's important, for them to know for the project. Next thing, so each individual engineer working on this, because again, like, we're a multidiscipline company. Some of my projects, I have all the disciplines working on the projects. Everybody's responsible for doing their own code research. So you would, let's say the project is in Florida, the codes there might be very different than those that are, like, out west in New Mexico. I'm just thinking of, like, for example, New Mexico has a lot of seismic requirements for earthquakes. Florida has a lot of, in the realm of electrical, lots of lightning issues. So yeah, it's important each place you work to research local codes, make sure you're meeting those. This next bullet point, site visit, you may or may not have this on a project. We do both renovations and existing building expansions and things like that, and new construction. So for totally new construction projects, there would be nothing really for electrical to see at the site. So then in that case, there's no initial site visit to look at existing conditions. I gave an example of existing conditions site visit for the apartment project I walked through. That was totally necessary for that project. I couldn't have done the project without going there. Um, then we have the next several phases are kind of like designs phases. We're starting to develop our drawings. Schematic phase is pretty it's kind of basic. I like compare it to, I call it the skeleton of the project. Maybe you'll have some of these like single line diagrams where you're starting to communicate your intent through diagrams rather than putting things on like a floor plan. You're also at this point, you have to think we're at the beginning of the project. And most of my clients are architects. What do they care about? They care about anything that's going to take up physical space, because physical space is money. So this is the time I'm communicating to them, hey, we need an electrical room for equipment. It's going to be this big, and we need, 2 doors on it. They have to swing out. So they care about things like that. So we're going to talk about that at this stage. You might also develop a narrative, design narrative, talking about the things that you will put on drawings. Sometimes clients want that during schematic phase. And then you would be running preliminary calculations to do all of these things, reserve, like figure out physical equipment for space, develop single lines. Next is design development phase. This is all like building blocks. At this point, you're just building on what you did in the phase before. So you're now starting to work on your floor plans. You're maybe working on details. You're doing circuiting, coordination with your internal team members and your client. Next phase, develop specifications. So these are like notes. They're meant as like means and methods for the installing contractor. I'll use an example for like conduit. So this is the raceway that carries the cables everywhere. That is a different material depending on whether we put it outside, whether it's in a hazardous condition, whether it's in the walls in a building. We don't go through the pain of putting like notes everywhere all over the drawings, pointing at it, saying, okay, now it's outside, it's going to be this type. That kind of thing is taken care of in what's called specifications. These are either like notes on the drawings, or we have what's called book specifications, where there might be a whole like 8.5 by 11 PDF set that talks about conduit and nothing else. So depending on the project type, the larger projects call for book type specifications. The smaller ones, we usually just put notes on the drawings. The next step is permit submission and bid documents. So usually at this same level of completion for these purposes, permit submission is going to the AHJ, which is authority having jurisdiction. So like, for example, if I'm working in Chicago, that would be the city of Chicago would want to see permit drawings, and they have somebody who reviews our drawings there and would make comments on them if they had any, and we would have to address them before receiving a permit. They cannot be built, of course, until you get a permit. Bid documents, so usually clients will want to bid out their work to make sure they're getting a fair price for the build. So they'll send our documents, usually the same level of completion, to contractors and receive at least 3 bids, and then make a decision from there. Construction administration phase. This is one clients don't always, if they're trying to save money, they won't ask us to do this. So this isn't necessarily a part of every project. It's definitely Usually a part of larger projects. They want us to be involved during construction. This means going to the site, kind of like observing what the contractor is doing and making sure that everything's being installed per our drawings, especially for a final, it's called a punch list, final inspection, like where we walk around and make sure everything is correct. It's also a time where it's where contractors, if they have questions, they're allowed to contact us and ask those questions. Those are called RFIs, requests for information. And we review submittals from the contractor. So I used conduit as an example earlier. They would submit actual like detail sheets or catalog cuts of different conduit, and we would review those and say, okay, like, is this the type of conduit I specified and size and everything that's on my drawings? So this is sometimes a drawn out long phase depending on the project. Record drawings is also not always something we're asked to do. In fact, this is pretty rare. Um, but some clients want this where whatever happened in this phase, construction admin phase, a lot of times the contractor will change things a little bit in the field from what we designed. That all gets picked up in this record drawing. So that's where we as the engineers would be going back and changing our drawings for what was actually done in the field, and we give those to the client so they have a better depiction of what was done. Otherwise, everything before this, we call design drawings. I mean, they're not, yeah, I don't know if you ever heard of the term as-built. They're not as-built, they're not record drawings. They're close, but they're not exactly what was done in the field. That would be a record drawing. Any questions on this, or how was it kind of trying to put these in order?
I think overall you can kind of see the like line of reasoning, and like granted you can kind of see as well like where you kind of have to go back and forth on things for a while, especially like getting client feedback and then fixing the design. Like it's kind of like a constant like push and pull, right?
Yes, exactly. This is like a very iterative process. I can say, like, yeah, just going back to what you said, that's exactly what it is. Things you do here, like in schematic phase, like development of single line diagram, it's not done here. It's not by any means finished. You're still going back and refining this in these other two phases. At this phase, it's a very like general block diagram. And then as you get to this phase, you're like, oh, that panel actually needs to be bigger than it was. I'm adding more load to it. I'm going to change it. Um, yeah, so it's a very back and forth phase. Right now I'm working on a large new construction baseball stadium in North Carolina, and I can tell you there's been a lot of between architects is constantly changing things, and there's a lot of players, no pun intended, in this project. There's a food service consultant and the owner of the baseball stadium has a lot, like of input. They already have the contractors on board. They have a lot of input and feedback. So things are constantly changing. So we're skipping back and forth between all these things to make the project right. And I think that's the end. Yeah, that was the end of my presentation. I'll open it up now to you guys. Anything you're curious about that I didn't touch on, or if you have any questions for me, I'd be happy to answer those.
Yeah, thank you so much. The presentation was amazing. I guess if you guys have any questions, feel free to like put them in the chat or ask them by unmuting. I think one question I had, would you be able to elaborate on like, I know now you're an engineering consultant and not necessarily doing electrical engineering, but is electrical engineering like solely the like figuring out solutions for the electrical systems involved in like industrial engineering?
It can be. I mean, like I have worked on industrial engineering projects, but I mean, like I feel like I've touched so many market sectors. So I do like multifamily residential. I showed you that project earlier. I'm working on a baseball stadium now. One of my projects is for a cheese factory at the moment. That's kind of like more manufacturing, industrial type. Um, we've done a bunch of Raising Cane's chicken restaurants. I'm sure you guys might have had that kind of fast food before. We do Starbucks. Like I've worked on, like I showed in my examples, airports, government type projects, uh, hospitality. So I've done a lot of hotels. Yeah, so I work on, and that's the same for anybody else in my industry. Like you can, a lot of places you work, you can kind of like have a large portfolio of different projects you work on. There are some companies I know of that have like divisions. So like some larger ones where they'll have or studios, they call them. So like if you get put in the residential studio, maybe you'll only work on multifamily, or the commercial studio, maybe you'll only work in retail. um, yeah, there's just it's kind of limitless. It's not just for industrial. It's like, yeah, you're figuring out electrical solutions for all kinds of things. Even at Kimley-Horn, like we have two different types of electrical. We kind of like slice ourselves in. So we have the vertical type, which is what I do, and horizontal electrical engineering, which is what a bunch of my partners do. So vertical type is like, think about buildings. That is vertical engineering. Horizontal type is like outside of the building typically. So it's like EV chargers and solar and distributions for the utility. So we have a lot of people who do that type of engineering, electrical wise at Kimley-Horn too. And there's some people who do both. Yeah, I do a combination of both. I've done plenty of like site lighting for parking lots and ATM drive-throughs, and yeah, it just runs the gamut.
Wow, that's awesome. Thank you so
Yeah.
much.
Yeah. Any other questions? I know somebody was having trouble um with their mic, so might be some in the chat. Okay, what advice would you give an aspiring engineer to an aspiring engineer? Um, I guess just to kind of like soak it all in when you start your career, try to find a good mentor that might not necessarily be your supervisor. um, one of my I feel like one of my treasures, the company I was at for 11 years, one of my colleagues, he unknowingly took me on as a mentee. Like I told him that when I was leaving, I learned so much from him. I feel like that so many of the things I learned from him, I go and teach others today. So yeah, just try to figure out like who that person is going to be for you, and try to soak up as much as you can.
I guess adding to that, do you wish you did anything differently in high school, like in regards to finding a mentor to prepare you for engineering?
No, I mean, like, I didn't have that mentor till I had my career. In high school, yeah, so advice I would give is to kind of what I did for myself. I was kind of like I felt pretty sure about engineering, but I also took a lot of other electives because I wanted to narrow it down or kind of like make sure. So I did I did take some like pre-law classes, and I thought I might want to be a veterinarian. So I took like anatomy and physiology. I was trying to rule out those other things, and I did. And then by the time I was a senior and picking colleges, I was focused on engineering. So yeah, I think that might be good too, to kind of just like try a bunch of things to see like if you like, not like I'm trying to talk you out of engineering. Like it would be great if you all became engineers, but that kind of helped me, I guess, like so that I didn't second guess myself when like should I have done something else once I got to college.
Yeah, that's amazing advice. I really think that like a lot of times when we're talking about careers, we don't often talk about like there's actually a lot out there too, especially
Yeah,
like with engineering, like you said, for electrical engineering, I didn't realize there were so many outlets for like students to like
There are, yeah, there are so many different types of electrical engineers. Yeah. One of the reasons I became one, my older brother is an electrical engineer, but he writes code for widgets and things. And I don't even think we know what each other does, but we're both electrical engineers. Yeah.
um, I'm not sure if anyone else has any other questions, but are we free to also like share your email if anyone has any questions they want to ask, like
Yeah, of
looking at the
course. Yeah.
recording and stuff?
Yeah, of course. Feel free to do that. I'd be happy after this call to answer any questions or have a call if you guys want to. Yeah,
Yeah.
that yeah.
So, and then I'm not sure if you saw the what's it called? The PDF we made for the case design challenge.
I didn't see that. Feel free to share
Yeah, I'll email
screen.
it. We like shared that with our members to give them like a debrief on the design. One, two, three. Um, I'll just send it on the email chain really quick. Okay, I just sent it as an attachment, but I know we only have like 9 minutes left, so I'm not sure if you wanted to like share your general thoughts, like just looking at the project, how you would approach it for those
Okay.
to submit.
Yeah. So this was the one where we were designing a space like with post pandemic in mind, right?
Yeah.
Yeah. So some of the things that like the firm I was at Epstein when the pandemic happened, we actually as a group participated in a contest to like present our ideas and we won. Like so, yeah, I just thought this would be like a fun one for you guys too. So just some random like things, and this includes not just engineering but architecture too. So there are like cover plates that you guys might have seen these in elevators that you can put on electrical devices like the elevator buttons that have like a film that after you touch them, like it kind of like I don't know, takes away the germs somehow. So yeah, that's one. Of course, like HVAC systems, you can put like filters on those to kind of make the air quality better for the occupants in the building. Um, Everything like can be automatic, right? So energy code already forces lights to be this way in commercial buildings. So that's really nothing new. But thinking about like restrooms for the occupants of the building, the soap dispensers, the faucets, the flush valves, paper towel dispenser. Those can all be touch free, right? So that's another thing we can do. Um, we can make, like we can kind of shuffle around like the way that people work. Um, Maybe with the way hybrid is now, more kind of like hoteling spaces for workstations rather than individual, where you're also kind of like thinking about saving money, right? Maybe you don't need that whole all that square footage for your tenants if they're working from home half of the week. So that's something else to think about there. Trying to think if there are any others. Those were the first that came to mind. Did you guys have any you want to share with me that you put into the document?
Yeah, so mostly what I've been doing is like, I'm not sure if you've heard of like Pinterest, but I love
Oh
Pinterest.
yeah,
So just
yeah.
like putting together designs and like solutions from there that I've seen for like office buildings. And one of the things was actually similar to the bathroom. It's the foot pedal that you put on the door, so you like step on
Oh
it
yeah.
rather than like having to grab the door handle. No.
Yeah, that's a good one. I just got your email by the way, so it's
Oh yeah.
opening it up. I don't know if anybody else wants to. Oh, this was just, it was the PDF kind of
Yeah.
explaining. I see.
Yeah, kind.
Okay. Well,
I think like in being able to incorporate like the having like some sort of TV and like area to actually communicate with people on Zoom and the people in the office. Because like you said, like sometimes people are working from home like 3 times a week.
yeah, yeah, that too. I think we saw like an uptick in design, like the way conference rooms are designed. Like I'm sure like a lot more IT was involved with incorporating screens and everything because even now, like the place where I work, we're 5 days a weekend, but we're a national company, so we work with other folks at Kimley-Horn all over the country. So we have TVs in every conference room, and there's often somebody who's on the screen and not actually in the room with us. So I saw that happen a lot after the pandemic between hybrid and all.
Yeah, for sure. I guess looking at it too, how would you see like electrical engineering kind of playing into that? I guess like you said with the IT having to like incorporate the technology, right?
Yeah, and like even like the automatic everything. So that requires something, right? If it's a battery, then we're not getting involved because that's a yeah, that then they don't need our power, right? But if it's an outlet, like if those soap dispensers need something to plug into or hardwire, then we're needing to bring power to those things that are automated. Yeah, so that's whether it's like a low voltage kind of like thing or it's actual like line voltage where electrical is getting involved there with the automation things. The same with HVAC, like even though I'm not a mechanical engineer, to kind of like put filters or UV lights and like HVAC equipment to kind of like filter out the air. That's all engineering too.
Yeah, for sure. It's so interesting to see too, because like I guess this challenge is more like architectural design, but it still requires like the skills and knowledge needed, like from engineering principles.
It does, yeah. We work so closely with architects for solutions, yeah, and often like one thing affects the other. Yeah, so that's true.
I guess do you ever see yourself like uh I guess having a dissenting opinion with an architect, like during the design process?
Sure. Yeah. A lot of times it's like, yeah, or it's a lot of times it's coming from client because they want to save money.
Mhm.
I'll just like give an example of it. Energy code like forces automation of lights. The latest ones actually make it so, and I don't know if you guys ever noticed this in commercial places, but or in office buildings. They make it now so user has to decide whether the lights go on or not in a lot of places. Even though it's called a vacancy sensor instead of an occupancy sensor. So instead of lights automatically coming on when you enter a room, it's it's manual on, automatic off. So user has to say, okay, well, it's dark in here. I'm gonna go press the button and turn on the lights. And then when you leave after a certain time, they'll turn off. A lot of times like clients don't like change. And then it's relayed to architects. So yeah, they might be like, well, I don't like that. Like I don't like having to go search for the light or um, occupancy sensors when those were first mandated. People don't like those either. They're like, I hate how, like the lights just pop on and I don't want them to. But yeah, code kind of forces us to go into things we don't like sometimes.
Okay. Not sure if anyone else has any questions, but I think it might have been a little rough for everyone to get out of bed this morning.
Yeah, I don't blame them. Yeah, it's a cold, snowy Saturday.
But thank you so much for joining us. And
Yeah,
I'll
yeah,
definitely
thank
forward
you
your email
guys.
to all our members so they're free to email if they have any questions.
Yeah, of course. Yeah, I would be happy to talk to anybody after this. Feel free to reach out.
Yeah. But truly, thank you so much for joining us today. It was
Yeah,
so incredibly insightful.
okay. All right. Well, great. Yeah, I hope you guys have a good new year. You have a great rest of your day.
Yeah, thank you. You as well.
Okay.
Bye.
Bye.